in this question we have to find the acceleration of A and B after this string is cut. Now let's consider the situation before the string is cut. Let's consider this situation first. So what are the forces here? See, this string, it has a tension. It is balancing the weight of the object B. So the tension here, if I call it T1, the T1 will be equal to mass into acceleration, the weight of this m into g. So if we draw the free body diagram, so for object B, the downward force is mg and the upward force is T1. So since this is stationary, so here T1 is equal to mg. Now let's consider the object A. So here, since T1 is acting in this direction, so this will also act in this direction because this is a tension. Now what about the force here? So if I call it force of the spring F, so this spring is taking the weight of both objects A and B. So if we draw a free body diagram of A, so this downward force on A is its weight 3 mg plus T1, and F is upward. So from here we get F is equal to, since this is stationary, 3 mg plus T1, T1 is mg, so this is 4 mg. So force on A in the upward direction before the string is cut is 4 mg. We could have arrived at it straight away like this. So this spring is taking the weight of both A and B. Their combined weight is 3 plus 1, so 4 mg. So F is equal to 4 mg. Now let's consider the situation when this string is cut. So say this is cut. Now when this string is cut, immediately after, so the question is asking us immediately after the string is cut. So when immediately after the string is cut, the force on A will remain as 4 mg. So the free body diagram of A, upward force will be 4 mg. Immediately after, the force will remain the same, so it is 4 mg, and the downward force is its weight. Its weight is 3 mg. So this is the free body diagram of A. The free body diagram of B will be, now since this string is cut, so there is no upward force on this, so there is only one downward force on it, which is its weight, which is m into g. So once we arrive at this free body diagram, we can easily write this equation that net force is equal to its mass into its acceleration for each body. For body A, net force will be upward is 4 mg, downward is 3 mg. This is the net force, and its mass is 3m into its acceleration is, say, a1. So this will give us a1 is equal to g by 3. M will cancel out 1 by 3. So this is j by g by 3. For this body B, its net force on it is mg, its mass is m, and say its acceleration is a2, therefore a2 will be equal to g. That means acceleration of body A is g by 3 and acceleration of body A2 is g, which is option B. That is option 2.